Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or you want to test out the project you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you get everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. This week's episode is also sponsored by Data Coral. They provide an AWS native, serverless data infrastructure that installs in your VPC. Data Coral helps data engineers build and manage the flow of data pipelines without having to manage any of their own infrastructure. Data Coral's customers report that their data engineers are able to spend 80% of their work time invested in data transformations rather than pipeline maintenance. Raghu Murthy, founder and CEO of Data Coral, built data infrastructures at Yahoo and Facebook, scaling from mere terabytes to petabytes of analytic data. He started Data Coral with the goal to make SQL the universal data programming language. Visit dataengineeringpodcast.com/datacoral today to find out more. You listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as Dataversity, Corinium Global Intelligence, Alluxio, and Data Council. Upcoming events include the combined events of the Data Architecture Summit and Graph Forum, the Data Orchestration Summit, and Data Council in New York City. Go to dataengineeringpodcast.com/conferences today to learn more about these and other events and to take advantage of our partner discounts to save money when you register. Your host is Tobias Macy, and today I'm interviewing Shruti Bhat and Venkataramani about Rockset, a serverless platform for enabling fast SQL queries across all of your data. So, Shruti, can you start by introducing yourself?
Thanks so much for having us, Tobias. My name is Shruti Bhat, and I am head of product here at Rockset. Prior to Rockset, I was at Oracle for a little while, where I focused on strategies around IoT and AI. And prior to that, I spent some time at VMware and another startup.
And Venkat, how about you?
Hi, thanks for having us, Tobias. My name is Venkat. I'm the founder and CEO of Rockset. Prior to starting the company, I was managing online data infrastructure at Facebook from 2007 to 2015. Helped scale the online data backend from 50 million monthly active users to about 1.5 billion. This was the set of systems and services that was responsible for storing and serving all Facebook user data, and all the Facebook products, user-facing products, were built on top of. The philosophy out there was to make it easy to build data-driven products within Facebook, and now with Rockset, we carry the same mission to make it easy to build data-driven products and services, but for anybody building applications in the cloud.
And the requirements at those different levels of scale is definitely interesting. I'm curious to understand if the necessary amount of resources scaled sublinearly or superlinearly in relation to the number of users.
If it were scaling linearly from where we started, I don't think Facebook would have been a profitable company. So I think it had to scale sublinearly. But the thing that we used to say a lot about is, from in those 8 years, the user growth was 2 orders of magnitude, but the data infrastructure kind of demand was probably 3 to 4 orders of magnitude more, because the product got a lot more richer and lots of other features were launched, and that added a lot more demand on the online data management system than just user growth. I used to joke about this and saying the most predictable thing about Facebook was actually user growth, and it's the product launches and the impact a new product launch would have on the online data infrastructure was the harder problem that was harder to predict, harder to capacity plan and everything.
So after leaving Facebook, you ended up starting Rockset, and I'm curious if you can describe a bit about what it is that you have built there and your motivation and inspiration for creating it.
Yes. So it didn't immediately happen. I spent about a year really trying to understand what are the problems worth solving in the real world. As much as Facebook was a great learning experience, I think the real world is a lot different. The complexities are different, the challenges are different, and I spent a lot of time talking to, I didn't have a company, I didn't have a product, so it wasn't really a sales pitch, but just really started talking to a lot of the real world companies out there that the banks I do business with, the hospitals that I go to when I'm when we get sick, and companies like that are way outside the Facebooks and the Googles of the world. Then just understanding what problems are worth solving, and that's kind of like that journey is what I think led and gave both the insight and the motivation to go do something about it. And so the motivation really came from how complex it was to build data-driven products and services in the current age where we live in. On one end of the spectrum, I would say the previous generation technologies, whether it is transactional processing systems or warehouses and data lakes and what have you, I think they have taken the previous generation problems and have gotten a pretty good solution that is, I think, good enough for those use cases. But more and more companies, that is not where they were struggling with, but companies were struggling with in building, operational analytics and real-time dashboards and real-time insights for their operational teams. And in order to build that, I think almost always everybody. I used to kind of joke about this and say everybody was building a Rube Goldberg machine of sorts, where they're kind of duct taping together multiple disparate data management technologies in order to build those operational dashboards and APIs for real-time data processing. And so that's kind of like what started us on this journey and really motivated us to figure out, in this day and age, what would be a data management system built ground up that exploits the cloud, that is built ground up for this new age data management problems, and what is the simplest and the most powerful product that we can build that actually is makes it really, really simple and easy and accessible for a lot of people to go and make their companies and make their products a lot more data driven. And so that's kind of like at the high level, I would say, was our motivation to go do something about in this space.
So at the 10,000 foot view, what you're doing in some ways could be equated to what other projects such as Snowflake are doing as far as using cloud technologies to allow for scaling compute and storage independently and being able to ingest data and then be able to perform analytics on it in a SQL format. So I'm curious if you can dig a bit more into the types of use cases that Rockset is particularly suited to and some of the areas where you would use that in place of a cloud data warehouse or a data lake approach.
Sure, let me dig into that a little bit. I think the most common use cases we see are actually very different from something that a data warehouse can handle. For example, real-time dashboards or a developer API, or if you're trying to build a microservice on your data, it's incredibly hard to process a lot of your data in real time for two reasons today, right? One is, data is flowing. Second is the shape of that data is more fluid. What I mean by that is you have more streaming data and you have more semi-structured data. So how do you possibly process that in real time and build microservices or dashboards on that? But I can give you a more real example. For example, let's say you're building, I'm actually going to take a very real example here. You're building a gaming platform that, say, uses DynamoDB for transactions, right? And you want to help all your game developers by giving them APIs so they can monetize their games. They can ask things like, hey, who's using a certain type of sword in this game right now, and what have they purchased in the past? So very quickly, these queries are asking real-time questions, but also trying to join that with some of the historical data, but they need to know that right now so that they can monetize their game. So you're talking about complex queries involving joins, subqueries, aggregations, but then you also need that to be processed really fast. Now, this is not something that a data warehouse can handle simply because the kind of data latency and query latency you're looking at would not be feasible.
If I could add something to that, I mean, warehouses are very good at batch analytics, but when it comes to real time and like all the examples that Shruti pointed out, I think in lots of cases, you end up abusing a data warehouse or a transactional system to be able to build those kinds of architectures. And I think I think we built ground up to embrace that, both in terms of the speed at which data is flowing and how fluid the shape of the data can be and the structure can be evolving over time. And we keep up with all of that on the fly for you. So I think that's where I think we largely differentiate from existing products out there.
And so with Rockset, it seems that the primary use cases that it's aiming at are for these situations where you need to be able to do smaller query sizes, but at faster rates than what you would be doing with a data warehouse or a data lake, where you're trying to do some small scale aggregates on the order of maybe megabytes to gigabytes as opposed to terabytes to petabytes. And you want to be able to do it on data as it's arriving rather than having to ingest it and then do some measure of cleaning on it.
Yes, I think there is, I think maybe an introduction into like how somebody might use Rockset would be helpful here, just so that we can get some clarity on what that is, what that would look like. Say you're using DynamoDB for transactions or transactional data, or you're using Kafka for a lot of real-time event logs and it's coming in real time. Let's say that is coming in JSON or protobuffs or some other semi-structured data set. Now, in order to use Rockset, you get an account, you point us at these two data sets, whether it's a DynamoDB table or a Kafka topic, and in real time, we will sync all of the data, transform them into a fully indexed, really fast, fully structured SQL table. And that will happen in real time. You don't need any other pipelines or structural transformation logic that you need to build in order to achieve that. And we will automatically use, in this particular example, a DynamoDB stream or tail Kafka topics to be able to keep itself in sync. The shape of the data can evolve, new fields can get added, fields can change type, and our structural SQL representation of that in Rockset will automatically keep itself in sync. And on top of that, now we have a distributed, very fast SQL query engine that you can instantly start asking really complex questions, including joins and aggregations and what have you, just using SQL. So you can go now build your app or your dashboard or your API just using SQL. Now, in terms of batch analytics, yes, you're right. If you just have if your primary job is to store a lot of data and do occasional query processing on that, Rockset is not a good fit. You want to use a data lake and maybe use an open format to store it and occasionally use a batch compute system like, let's say, Spark or maybe even Presto type data management systems to be able to do that. But if you want to build a system of engagement on this data, then you need a powerful system that gives you the power of SQL. You need that to be fast so that you can build interactive applications and APIs on top of that. And it needs to be happening in real time, so you don't have to, you're not working on historical data, but live data that is coming in your, coming from your system of record or from your real-time streams. And those are the use cases we shine. And so we can do thousands of queries per second. The speed of the queries are dependent because of our architecture, because we index everything. The speed of your queries in a typical warehouse would be dependent on the size of your data set. But because we index everything, the speed of your queries in Rockset would actually only depend on the size of this, the selectivity of the query. Your data set can still be massive, but if you compute the where clause of your SQL query and you do let's say a count star on that result, that is what determines the speed of the Rockset query, as opposed to other warehouses where it really depends on the size of your entire data set that is being stored. And so, yes, we can actually manage, tens to hundreds of terabytes of data and do still, sub-second query processing on that. But again, the query speed depends really on a lot of the, on your selectivity of your query, as opposed to the total size of your data set.
In fact, my favorite customer quote along those lines was somebody who said, I did everything that's state of the art, and yet the best I could do was 30 minutes of latency and multiple hops, right? And that right there tells you that that's what state of the art looks like. In fact, this was an e-commerce company that uses Kafka for streaming data, generating millions of events per day from their web and mobile apps. And they need to ask some complex questions in real time, right? Like, is there a fraudulent transactions? What are my customers buying right now? Did our competitor just drop their price? They're tracking all these metrics now. All they have to do is send that raw data from Kafka to Rockset and answer all these questions just using SQL in real time. So that's the big difference.
So in a quote unquote typical architecture that somebody might be running, it sounds like some of the components that Rockset replaces are the ELT or workflow engine and the online analytical processing engine that you might be doing some of these queries in, and then possibly a few other components. I'm wondering if you can just talk through maybe some examples of pieces of infrastructure that people have been able to entirely do away with by moving to Rockset, and some of the ways that it fits into the rest of their overlying architecture.
So I think what would be nice to kind of like get on the, think about it at a high level, or what does a modern data architecture look like in the cloud? You would definitely need a transactional data management system for your, system of record. You would need, something, something like Kafka for your real-time event processing, which probably drains that into some kind of a data lake in the cloud. It's Amazon S3 or GCS or what have you. And you would use systems like Presto or Spark for batch compute on top of that system on the data lake. And then after that, on top of data in your real-time stream on your lake or from your system of record, you are going to build lots of systems of engagement, for your marketing operations team, sales operations team, support operations, security ops, DevOps even, and that is this set of applications and set of use cases that we shine at. And so typically, what we end up replacing there are for one set of use cases, it'll probably be something like Kafka landing data into Elasticsearch like systems where if all you need is a single table query on some real-time streams, then you'd use something like that. In other use cases, we also see complex, either ELT or ETL scripts periodically dumping data into parking lots like Postgres, where they don't really need the transactional capability of Postgres. They just need a good data serving system for their systems of engagement. And that is where all the hops and the complexity and the non-repeatable nature of the solutions come into picture, because they can't really keep up with both real-time data and the fluidity and the structural changes those streams are going to see over a period of time. And so those are the things that we end up replacing. A lot of the time it's 2 or 3 technologies cobbled together, but a lot of the time the serving system at the end of those pipelines end up being either Elasticsearch or something like Postgres, which is what we end up replacing in a lot of places.
So can you talk through the way that Rockset itself is implemented in order to be able to handle these various use cases, to be able to supplant those different pieces of infrastructure that people have been relying on?
Sure. I think we've written, our CTO has written a lot of good blog posts about it. Dhruba, we call it like the ALT architecture, which is aggregator, leaf, and tailors. So the fundamental contribution to this whole thing, that I think in architecture is how to exploit the fluidity of the hardware in the cloud. And so the aggregator, leaf, tailor architecture, what it does is, if you think about the tailors, which are the first, the ones that ingest and keep the Rockset, collections and the data sets in Rockset in sync with whatever the source of the data is. They automatically scale based on the amount of data flowing through the system, and that scales independently to the leaf nodes, which are where both the data indexing and the data storage happens, and that scales, basically independently of the other parts of the system based on just how much data is being managed within a particular account, in Rockset. And then the aggregators are again distributed in nature, and that is what does the distributed SQL query processing on top of the data stored in the leaves. And if I were to say, there's a lot more we've written about it in the blog post written by our CTO Dhruba. I encourage your listeners to go check that out at rockset.com/blog. And we built our own schedulers that auto scale every component of that independent of others based on both the demand and the SLAs that our customers are asking from us.
And on the storage layer, I'm curious what you're relying on to allow for the speed and flexibility that's necessary in the query layer for being able to serve those queries with such low latency in terms of the data ingest, and with the amount of flexibility necessary to be able to cover such different disparate data types and the semi-structured nature of the information that you're ingesting?
Yes, I think this is where we spend a lot of time. I could probably talk for another hour on just all the technical, I would say innovations that has enabled a system like Rockset. But at a high level, I would start with a couple of things. Number one, what is one technology that we use a lot is a storage engine called RocksDB, which Dhruba helped create, and I was part of the team. And in our previous life, when we were working together, we worked on this storage engine that is called RocksDB. That's quite popular as a high performance storage engine. So a best way to understand this is like InnoDB was the most popular storage engine for MySQL. Lucene is kind of like the storage engine for Elasticsearch, and for Rockset. RocksDB and an extension of RocksDB, which we call RocksDB Cloud, is the storage engine for Rockset. And so there's a lot of innovation and work that has gone into RocksDB, and then we have even made it even work much better in the cloud with RocksDB Cloud. And so that is a very core component that I think allows us to build the flexible architecture. We've also written about this in our blog post. I think I welcome your listeners to go check that out. Then the second thing I would also say is our type system. I think there's a lot of almost every other SQL data management system out there, SQL-based data management system out there, is statically typed and it's strongly typed. And I would say our type system is strongly typed, but it is dynamically typed, which is why we don't need people to describe to us the shape of the data ahead of time before they can start ingesting data into Rockset. And this is why we are able to put a very fast SQL layer on any NoSQL data sources or data formats that you have. And how do we do that? I think our type system is inspired from how a lot of dynamically typed, like language runtimes of dynamically typed programming languages would look like. Whether it's HHVM or other JIT like V8 like JIT runtimes that are able to produce a lot of efficient execution even on dynamically typed programming languages. So I think our execution engine is like very much on our data representation, data structure, internal data structures. We call it iValue, and Tudor from Rockset has written a pretty good blog post about that too. So that allows us to actually represent the data even though we don't know the type of the data ahead of time very efficiently and do very efficient data processing on that. And our indexing systems comes a long way. I think our indexing algorithms are a lot more inspired from distributed search technologies that we've helped build in our past lives than just data columnar data management systems and SQL-based data management systems and whatnot. So at a high level, we stand on the shoulders of giants. We have we are inspired a lot of amazing technical ideas from search-based systems, from dynamic programming like language runtimes, and from distributed SQL, optimizers and distributed SQL query execution strategies. And I think we're able to kind of like bring the best of some really, really awesome ideas from all these different disciplines into a single product with Rockset, which is why I think we're able to provide a very powerful abstraction, which is just fast SQL over any of your data, which is, I think, is probably the simplest way to present a lot of these innovations to all of our customers.
And in terms of failure modes and recovery, I'm curious how you approach distribution and balancing of the data and ensuring proper replication. And then in terms of recovery modes, I'm curious what you're relying on as far as being able to replace failed nodes and then redistribute data.
Excellent question. So RocksDB Cloud, I think I briefly mentioned, is the key ingredient here. So I'll give you an example of how, at a very high level view. I'll give you how it works, and then an example of what happens on a failure. And I think that kind of like would answer your question pretty well. So RocksDB Cloud. So RocksDB is a storage engine. It's a log structured merge tree implementation. It's something that is open source, and there's a lot of literature around it that you can go read. RocksDB Cloud is an extension of that in the cloud, where all the data that is persisted in a local instance, let's say an EC2 instance in AWS, is also backed up in S3 as an S3 object. So every time RocksDB creates a new SSD file locally, RocksDB Cloud's implementation of that will also make a copy of that in S3. And so what it allows us to do is cleanly separate the performance layer of our backend from the durability from the durability. So the queries are fast because there is a full copy of the data in local SSDs and a lot on SSD media, which is I think very, very fast. So we are able to provide very high performance queries on a lot of these distributed data sets that is being managed in Rockset. But we also have a durable copy of every one of those SSD files in S3. And so say a pod fails or a node fails, and a different node now picks up that particular shard or that particular data set, and it opens the RocksDB Cloud instance, and it realizes that local SSD files are missing. It'll automatically download the latest backups that are being kept in S3 to the local instance before it will kind of open the database and be able to serve it. And so that gives us a lot of fluidity where recovery is almost a very normal part of the process. So we can scale up and down, deal with node failures, pod failures, disk failures almost very naturally, because all we have to do is just kill that node without having to worry about any recovery, start off a new replica elsewhere. And even if you have two replicas and one replica is down, we can bring up another replica without adding any more load to the current replicas that are serving the traffic, because the downloads are happening from S3 and it's completely isolated from production traffic. And so RocksDB Cloud, it's a very simple idea on top of RocksDB, but actually gives us so much fluidity in terms of resource management, durability, recovery, and failover semantics are just so much more cleaner and simpler, which allows us to actually fluidly scale the infrastructure up and down in the cloud than any other distributed data management system that I've had the pleasure of using prior to building this at Rockset.
And another thing that I noticed while I was preparing for this interview is that in the white paper that you have available on your site, it mentions that you're relying on Kubernetes for being able to handle deployment and scaling of your microservices, and in order to try to remain cloud agnostic. And then you were saying how the durability and reliability aspect of the storage layer that you're using is reliant on cloud object storage. And so I'm curious how the cloud agnosticism has been playing out for you in terms of being able to interface with different cloud object stores, but also for the cases where somebody might be consuming data from different cloud environments, how you approach latency mitigation for those users.
Yeah, that's a great question. So, the way Rockset is built, it can run on any cloud. You're right, because of how we use Kubernetes. But right now, it lives in AWS. But the key thing to remember is that we ingest and index all the data. So even if your data lives in any other cloud, or even if it lives on-prem, what we will do is we will sync with your data source and we will ingest all that data. And then the most important thing is we don't federate back to the source, right? So we terminate all the queries. And this is why no matter where your data lives, once Rockset has ingested it, we will give you very reliable query performance. And this is very important, right? If you're a developer building microservices, you really need that kind of reliable query performance. We cannot afford to federate back to the source. Like you mentioned, if your data lives in a different cloud or it lives on-prem, it'll take us forever to serve those queries. So that's the most important thing. And our indexing is, Venkat touched upon this a little bit, but our indexing is very interesting in that we do search indexing as well as a columnar, and we have a document index as well. And that's what gives us the very, very low query latency. Now, one thing you might ask me is, well, what are you going to do if you have flash floods, right? Sure, we're ingesting data wherever it lives. What if, it's say a Kafka stream and you have a flash flood of data coming in? Again, as Venkat was saying, we scale our ingestors separately from everything else. So we make sure that we meet the SLAs. If it's a few seconds of data lag, like if it's 2 seconds of data lag that you expect from DynamoDB or say from your Kafka stream before you can start querying it in Rockset, well, all we have to do is make sure that we scale up our ingestors to handle those flash floods and still meet your data latency requirements. So that's the way to think about it. Currently, we live in AWS. That's not stopped us from ingesting data from Google Cloud Storage. We have customers using Google Cloud Storage, and we have a native integration with GCS that customers can use right away.
Can you talk a bit more about the indexing strategy that you're using to allow for optimizing on so many different query types, such as search and graph and time series, which I know that you highlight in your documentation, and any challenges or complications that you've run into in the process of enabling those different use cases?
So yes, I can talk about that. So we build right now out of the box. We index all the fields and we organize all incoming data in primarily three general purpose indexes. An inverted index for you can also think about it as a search index on all those fields, a columnar representation of all those fields and a row-based representation of all these fields. So there are a few implications of that. The biggest positive of that is our optimizer understands these different strategies. So if you run a query that says, find me the average age across the entire data set, then it understands that I probably should just do a very quick columnar scan, just the fastest way to retrieve all the data that I need to process the query. But if you run the exact same query with a very complicated where class, where you only are looking at certain records with certain fields being certain values, then I think our optimizer will automatically use the search index to very quickly go from, let's say, billions and billions of records you have to the few 100,000 that match, and then do post processing once the data, relevant records and fields are retrieved using, let's say, the search index, and then do the post processing in parallel using our SQL distributed aggregation engine that we have. So the combination of our indexing strategy and that being built hand in hand with our query optimizer is really the key essence to making this work. Today we build 3 general purpose indexes. We are just about added geo indexing as another new feature. So new types of indexes are something that we're always thinking about, and also better and better automatic optimization strategies to exploit peculiar patterns in the data, peculiar patterns in the queries, so that we can continue to provide really good performance for a large spectrum of SQL queries for our users. And the one other really important aspect of all of this is time series data. And so that is also something that is a first order concept in Rockset, where every record that comes in can be, there is a special field in that record that we call event time. And so you can actually, by default, it will be the time at which that particular record was inserted in Rockset, but you can actually supply that based on any other fields that might be existing in your data set. But and these this event time is an optimization that is kind of built into our indexing strategy. And so whenever you have a query that has a complicated where clause on event time, or an order by event time, let's say descending because you want the most recent records of all the ones that match, or you want to do any aggregations across this particular field, that is already out of the box, really highly optimized in our query processing. And so you should expect very, very fast performance for time series data, because our indexing strategy takes the time for every record as a first order indexing concept. And our optimizer is aware of that concept that we have. And so yeah, the high level, our indexing strategy combined with our custom built query optimizer, SQL optimizer, is why I think we're able to provide really good performance for such a wide spectrum of query workloads.
Can you talk through a bit of the user aspect of getting started with Rockset and integrating with it? And then, because of the fact that Rockset is able to handle a number of the different systems that a data engineer might have been involved with managing, what are some of the ways that you've seen them use the extra time that they gain by implementing Rockset?
Well, that's a great question. I think it in almost every case, people's very quickly, within like the first few minutes of them starting to use the platform can go from, let's say, a DynamoDB table or a Kafka topic to a fully schematized and fully indexed SQL table. As I said, all you need to do is go to rockset.com, sign up for, go create an account. It's self-service. Give us read permission using cross-account role-based access or IAM user-based access. If you are using DynamoDB or if you're using Kafka, download and install a Kafka Connect plugin to connect your Kafka cluster to Rockset using secured API keys and what have you. And in a matter of minutes, you have now records flowing into a SQL table. And I think, as Shruti pointed out, even if your DynamoDB table is terabytes, multiple terabytes or really, really large, we auto-scale the ingest and whatnot. And still within a few hours, you should expect that to turn into a very, very fast SQL table on which you can ask any question via SQL. And so what we actually see with all of our customers, especially data engineers and developers, is that they get to move a lot faster. What used to be 3 people working on it for 3 weeks for a particular project now happens in a single day. And so data engineers end up now spending a lot more time with their business stakeholders, understanding their needs, give them access to the data that they need and the correct data sources in a correct format, and then just spending a lot less time wrangling data pipelines and scaling them, monitoring them, doing a lot of DevOps on their data pipelines. And more than that, fixing ad hoc scripts they had written for structural transformations of like NoSQL data to load them into SQL-based data management systems. And the developers using us to be able to build search APIs and other microservices or serverless data APIs on top of data, they now have a fully isolated live SQL replica of the DynamoDB table or of their Kafka topic. And I think they're able to build microservices without having to worry about affecting production transaction processing systems. They're able to move a lot faster, not worry about scaling this and building pipelines or anything like that to keep it in sync. And so I think they just now again can spend more time with product managers, their end users, make sure that the product they're building is actually useful and producing the results that they want and build a more engaging, useful product for their end customers. So I think it's just giving a lot of time back to our immediate users who are developers and data engineers that now they get to spend the time on adding value to their business, to their product, as opposed to wrangling data pipelines and fixing ad hoc ETL scripts.
And what are some of the most interesting or unexpected or innovative ways that you've seen people using the Rockset platform?
Oh gosh. So one of our favorite ones actually is the state government heritage program. It so happens that we're all nature lovers here at Rockset. In fact, if you go to Venkat's house, you'll find a wall full of posters of national parks. And then here's this heritage program and a state government that's actually helping preserve natural species in several states actually through a real-time app that serves as an animal and plant field guide. So you can go in, you can search, filter, drill down on different species based on different criteria, and then that's helping them find species in the wild and then help preserve some of the natural species out there. So that just gives us the warm fuzzies. We really like that use case. And then another interesting way we've seen, I think apart from the types of use cases we've described, is there's this other company which is an automated checkout company. It's an AI-based system. Interestingly, what they're doing is they're helping their developers move faster. So the data engineering team is saying, hey, if I have to give my developers access to my database in production every time they want to go develop and test a new feature for our core product, it's going to take us a lot longer and slow us all down. So instead, they actually use Rockset as a way to just give APIs to all of their developers to just play with the data, experiment faster, develop their feature on it, and they don't have to worry about how would that impact their database in production. So we thought that was a very interesting, cool way of just accelerating your developer lifecycle and how data engineers and developers start working together when you give them new tools in their toolkit.
Yeah, it's definitely interesting to think about the possibility of mirroring application databases into Rockset for making it easier for developers to be able to gain access to it, but also for being able to expose it to business users or business intelligence engines so that you don't have to add read replicas or transform them into some sort of flat file representation to be able to load into a data lake technology. And I'm curious if you've heard any feedback from people using it for that type of implementation.
That's almost perfectly like a great summary of the most common use cases we see, where real-time streams, not just systems of record, as in this example that Shruti talked about, where it's a combination of these two, and then giving that access so that people can, you're building operational dashboards for your business teams, or giving that to your developers so that they can build serverless data APIs, let's say using AWS Lambdas or other function as a service in the cloud, so that they can build very fast APIs on top of that data, which combines, using joins and aggregations and what have you across both systems of record and all the behavioral data that you're getting in like event-based systems like Kafka and what have you. So that's a very good summary of like the most popular use cases that we see from our customer user base right now.
And then in terms of your experience of building and growing the technical and business aspects of Rockset, I'm curious what you have found to be some of the most challenging and exciting aspects.
It's a great question. I think what's most challenging is probably also the one that's actually most exciting because it's fun to tackle hard challenges. I would say the founding team, in terms of technical challenges and whatnot, I think one of the things is like, we've had an experience of both using and building lots of large-scale data management systems in our past lives. But when it comes to building those data management systems in the cloud, I think as a industry, I think we're still scratching the surface of the possibilities here. So, like if you think about technically speaking on what a data stack should look like in the cloud, whether you rent one machine for 100 hours or 100 machines for 1 hour, it costs you exactly the same. And so for the same price, I think things should be infinitely faster, relatively speaking, at least in the cloud. And so no real software stack can actually do that yet, which basically means the software stack has to be really reimagined and rebuilt in the cloud, especially when it comes to data management. And I think the eventual data management in the cloud will all be entirely serverless, end to end. And that is also one of the biggest value propositions of Rockset, because we are entirely end-to-end. We are a serverless data management stack. So you don't have to think about how many nodes do I need, pods do I need, and how much RAM, CPU, and whatnot. You simply point us at your data and start writing SQL, and we will automatically scale. You pay for what you use, and there are no idle clusters, and there's no capacity planning or provisioning that you need to worry about. And I think that is providing and building that, I think, is very challenging, but it's very exciting for that to come to light, and our customers leveraging kind of all the hard work that has gone behind the scenes to be able to leverage and very quickly build amazing applications and APIs using Rockset at this point. So I would say that would be probably, I would capture building serverless data management system and for the new age is both really challenging but also super exciting when you see that come to fruition.
And then looking forward, what are some of the new features and improvements that you have planned for the future of Rockset?
There's a very, very long list. Fundamentally, when we start talking about, we think about, the ecosystem that we need to work with, there are two major sets of things that we need to work with, right? Where is your data, and what kind of applications or system of engagement are you building? And so on one end, I think we want Rockset to be able to have a live sync and a live connector with wherever our customers' data happens to reside, whether it is a SQL transactional database, it's a NoSQL transactional system, or real-time streams in one cloud, multiple clouds, Kafka, or some other system like that. And whether it is a cloud SaaS like Salesforce, which is where your data is all locked up. So we want to make it very, very easy for people to like create a live SQL table replica of any of that without any pipelines or ETL or anything like that. And so that is one set of things that we'll always keep expanding and growing. And then the other side, there is a lot of different systems of engagement people want to build, internal tools that people want to build within their organization. And that we see our customers kind of like connecting Rockset with things like Retool for building an internal tool on top of Rockset. We see people integrating us with AWS Lambdas for building serverless data APIs. And so we want that workflow to be a lot better and smoother. And I think there's a lot of JDBC or REST based SQL-based dashboarding tools like Tableau and Redash and Superset and more tools like that I think we also want to be working with that ecosystem. And in fact, we recently announced our integration with Grafana as now Grafana dashboards can be powered by Rockset. And so yeah, in both these dimensions, I think we see more and more coverage and more work that we happen to be doing. And I think more in terms of our own backend, as I said, we're just scratching the surface on building 3 general purpose indexes. There's a lot of interesting research right now happening around learner indexes and other indexing strategies that can use advanced kind of like ML/deep learning ideas to build the most appropriate index for a given data set. That I think is a lot more, sometimes, it works, in some cases, works even better than the kind of indexing strategies that we have in place. And so how can we use more ML, DL type techniques to build a better optimizer, to build a better indexing strategy is also something that we're always constantly thinking about.
I think our vision really there is how do we make it easy to build more data-driven products and services, right? Venkat always likes to say that back when he was at Facebook, he used to say, hey, no developer should ever be bottlenecked on their infrastructure. And I think most of our customers, when we talk to the data team, they really believe in that vision, that they don't want the infrastructure to ever be a bottleneck. So where we're going is you should never have to worry about the source of the data, you should not have to worry about the shape of your data, and you should not have to worry about what type of queries are going to come in. So if you take those 3 things, really those are the 3 main questions that probably keep data engineers up at night, right? So we're saying, hey, if we can take these 3 things and just make it really, really simple, give you the kind of performance and scale that you expect, then data engineers should be able to go do more valuable things for their business versus just babysitting their infrastructure.
And one thing that you mentioned there in terms of some of the research being done to allow for some of these more complex and interesting index types, I'm curious, being a startup, how much of your time and resources you're able to dedicate to research, or if you're currently in the mode where you're full force on just product development and iterating on improvement cycles?
I think, I would say majority of our time, almost like overwhelming majority of our time is about building the product that our customers want, immediate customers want, and our potential customers want. And so I think we keep in touch with literature and make sure, it's more applied research as opposed to research in isolation of that. So we're aware of what are all the ways we could solve a problem. And if we find for a particular use case of particular feature development that we're doing on behalf of what the product needs are, our customers' needs are, and that particular approach that comes out of literature is the right thing, we will go build it. But it's a lot more applied is how we think about it. We're not trying to invent necessarily new learner indexes, but once in a while we experiment with it. Let's say in a hackathon or something like that, and then take a benchmark, take a workload, and see if you're able to replicate the results and understand that better, so that for the right feature or for the right customer, for the right use case, we know that there is another trick up our sleeve that we can kind of like employ. So I think we keep in touch with that. I think we're very well connected with that ecosystem, and so it's something that we're always keeping an eye on. But I don't think it makes it into our product roadmap until we see a clear need for either the product or for one of our customers' use cases.
Are there any other aspects of the work that you're doing at Rockset or the use cases that you're targeting that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I think one thing is when we say SQL or NoSQL, it's a kind of a catchy way of saying it, but it's really, what is it? It's it's saying that it's not a transactional system, right? We're able to do all these things because we're giving up on transactions. So if you think about it, we're sort of this operational analytical database in some sense. We call it a search and analytics system. But what does that mean? It means A, we're not a transactional system, so we're not your system of record. And B, we're not really a warehouse. We're not for historical batch type analysis on petabytes of data. But then what we're ideal for is those millisecond queries on terabytes of data, fairly large data sets with terabytes of data. And what does that mean? Use cases, it always comes back to, well, how do you build your real-time dashboards and give developers APIs and build your microservices without having that 30-minute lag and multiple hops, right? So it all comes down to, for us, I think the two core tenets that we always think about are speed and simplicity. How do we give our customers speed and simplicity? That's literally the one thing we always ask ourselves before we make any new feature decisions.
All right. Is there anything else that we should cover?
No, I thought that was pretty good. From your perspective, is this all the, have you gone through all the questions? Do you have any other questions for us?
No, we ran through all our questions. So for anybody who wants to get in touch with either of you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I would just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
What's the biggest gap? I think the biggest gap, as I said, is in this space where, lots of data coming from different data sources and whatnot, and people building systems of engagement on that very easily. I think the gap that we fulfill is where I think a lot of the complexity lies, is where all the Rube Goldberg machines are built, is where I think there's just not one good solution built ground up for these set of use cases. All databases on both ends of the spectrum are very good at managing the data where they are the source of truth. But not when the data is coming from elsewhere or getting synced from elsewhere. So that's, I think, like the fundamental kind of gap we see in data management systems. The older generation or the previous generation technologies are very good at transaction processing or analytical processing, at scale. But operational analytics and operational data processing is what I think is the big frontier where it still feels like there's a huge gap in the tooling, which is what we hope to fulfill for all of our customers.
Well, thank you both very much for taking the time today to join me and discuss the work that you're doing with Rockset. It's definitely a very interesting platform that empowers a lot of interesting use cases that were previously fairly impractical or intractable. So thank you for all of your efforts on that. And I look forward to seeing how you progress along your goals. And I hope you enjoy the rest of your day.
Thank you so much. Thank you for having us. We really enjoyed this conversation and appreciate you having us on the show.
I have only one question for you, Tobias, before we sign up. So if your listeners want to follow up with Rockset, it would be cool for them to know that, we can, they can just go and sign up for an account at rockset.com. They don't need to contact sales or anything like that. Is there a way to communicate that to your listeners at this point?
Well, you're still being recorded, so you just told them. And also I'll add links to the show notes for anybody who does want to follow through and click through and sign up and test it out.
Yeah, if you want, if you're interested in Rockset, you can go and sign up for an account. No credit card required. It's free to get started. The first 2 gigabytes it's free forever. You just go to rockset.com, click on the sign up button, and get started if this is something that you think would be helpful for you. All
right. Well, thank you again, and have a good rest of your day.
Thank you.
Thank
Bye.
you.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.